Hello, thank you for watching this video. So in this video we're doing question 1 of November 2024 question paper mathematics paper 1. And the topic are equations, or solving equations. So let's go. At 1.1.1, they're saying solve for x, and at 1.1 we're given a series of equations, right? We're given a series of equations. There are quadratic equations, there are quadratic inequalities, there are exponential equations, and set equations. Are you with me? So that's saying now solve for x, and at 1.1.1 we are given x times x minus 3 to be equal to 0. So here we're taking the product of two things, and the product is 0. So you're multiplying two things and the product is 0. So what does that mean? If the product of two things that you're multiplying is 0, at least one of them is 0. So either this one is 0 or that one is 0. Are you with me? So in that case, we have our x is equal to 0, or x minus 3 should be 0, because to achieve a product of 0, at least one of your things that you're multiplying should be 0. Are you happy? In that case, you just get your x equal to 3. So your x equal to 0, your x equal to 3. Because if your x is 0 and you put 0 there, 0 times whatever that is inside here will be 0. Are you with me? And if your x is 3, you substitute your 3 here and substitute 3 here, this bracket will be 0 times whatever that will be outside. It will also be 0. Are you happy with that? Okay. Now, we move to the next one, 1.1.2. So, you are given an equation to be 2x squared plus 1, right? Is equal to 4x. So, next to this question, there is a hint. They said correct to 2 decimal places. Are you with me? Yeah. So what does that mean? Correct to 2 decimal, we know that, which is round off to 2 decimal points. But I think what they are trying to tell you is that this thing might not have very nice factors. So the factors of this thing may be irrational, you know. So the most efficient way, or most safest way to solve this would be to apply the quadratic equation, right? So the quadratic formula is, actually you must first write in the standard form. So let's take this thing to the left hand side. So if you do that, we have 2x squared minus 4x plus 1 is equal to 0. So once it is in the standard form, you apply the quadratic formula. You know your quadratic formula says x equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Are you with me? In that case, it's okay. My x is equal to negative b. What is my b? Minus 4 plus or minus the square root of what? Negative 4 all squared minus 4a. What is your a? 2. Your a is the 2 coefficient of x squared, and c, the constant, is 1. Are you with me? Yes. All over 2 times 2. Are you happy with this? Yes. So your x is equal to, or your x is equal to. So what is the answer? 0.7. It's 1.71, and the other one is 0.29. 0.29. So these are your factors. So these are x values. Are you happy with this? Yes. Are you happy with these solutions? Yes. Okay. Now we move on to 1.1.3. So it's also an equation. It's a quadratic inequality. We are given that x squared minus 2x minus 3 is greater than 0. Are you with me? It is close. It is in a standard form like that. You don't do anything. The only thing that you have to do is to find the critical values. Are you with me? So let's go and find our critical values. So x squared minus 2x minus 3 is equal to 0. And then we factorize this thing. So the factors, or you can use a quadratic formula to find the values of x. So you have x, you have 3, you have 1. So it should be minus 3, it should be plus 1. Are you happy? In that case, you are multiplying 2 brackets and the product is 0. At least one of them should be 0. It's either your x minus 3 is 0 or your x plus 1 is 0. So your x is equal to 3 or your x is equal to minus 1. Are you happy? These are your critical values, right? And you know what kind of function this one. This one is a quadratic function. Just have to draw it and show your critical values. That's what we're going to do. So if we do that, it's okay. Is it? Is it? Are you with me? Okay. So in that case, our critical value is minus 1. Are you with me? And 3. This is supposed to be minus 1 here. So if you plot it, It is a positive parabola, something like this. Are you happy with this drawing of mine? So you want it, weight is what? Weight is above 0. Weight is positive. Where is it positive? It's positive above this point on the left hand side of 3, which is all the y values up here, and it's positive up here. Are you with me? The corresponding x values are the x values that are directly below it, which is all the x values that are on the left hand side of 3. And all the x values that are here, which is on the, or there should be on the right hand side of 3. And these that are on the left hand side of minus 1. So in that case, you can say our x should be greater than 3. Are you with me? Or our x is less than minus 1. Or if you want to be fancy, because these are the solutions, if you want to be fancy, you can say x an element of negative infinity to where? To minus 1, together with what?
3.
With 3 to positive infinity. So these two and these are the same thing. Are you happy so far? No problem. Now we're going to 1.4, which is 1.1.4. Here you're given an exponential equation. So it is 2 raised x, 2 raised 2x minus 2 raised x plus 2. Are you with me?
Minus 36.
Minus 32 is equal to 0. So this is an exponential equation. It looks like it, right?
Yes.
So let's just break this down so that this looks similar to this. So this is 2 raised to x minus 2 raised x times 2 raised 2 minus 32 is equal to 0. Are you happy with this? What is 2 raised 2? 2 raised 2 is 4. 4 times this should be 4 times this. Are you with me? So what you need to do is just write it in a much more cleaner way and have this in front. Are you with me? So you have 2 raised to x minus 4 times 2 raised x minus 32 is equal to 0. Are you happy? Are you happy with this?
Yes.
And then what do we say? These look similar, but they're not the same. This and this. You can see it have 2x and they have x there. Try to write them in a way, try to write them such that they look similar. So what do? This, your 2x is also the same as x times 2. Are you with me?
Yes.
Are you with me?
Yes.
So in that case, you can take out your 2 as some sort of common factor and say, okay, I have 2 raised x, and then you put a 2 there. So this is 2 times x, which is the same as that. Are you happy?
Yes.
Are you sure? Are you sure?
Yes.
Okay. Minus 4 times 2 raised x minus 32 is equal to 0. If you look at it, it starts to resemble the quadratic equation. Look, this squared, you can see it there. This 4 times this x, you see that, and this is that. You see that there's a resemblance between these two.
Yes.
Are you happy with that? So in that case, let's let 2 raised x equal to m. Are you with me?
Yes.
Or maybe let's let it to be k. Just that's what people are used to. So in that case, you have k squared minus 4k minus 32 to be 0. Then if you can factorize this thing, 0, you can have a k here, you have k here. I think you should have something like an 8 and something like a 4. It should be a minus, it should be a plus. Are you happy with these factors?
Yes.
Are you happy? So we find that your k is equal to 8, or your k is equal to minus 4. But these are the values of k. What are you looking for? You're looking for the values of x, because you're asked to solve for x.
Yes.
So what do we do from here? We bring back, we said our k, we allowed k to be called 2 raised x. So let's bring back the 2 raised x and put it there. So look at this now. So you have 2 raised x is equal to 8, or the 2 raised x is equal to minus 4. Let's start with this. So you can find the factors of this. So your 2 raised x is equal to 2 raised 3. Therefore your x is equal to 3. Are you happy with this one? No problem. Now, if you come to this, what kind of graph is this one?
It's an exponential.
It's an exponential. What kind? It's a negative or positive exponential?
Is it what?
Is it a negative or positive exponential? It's positive. It is above the x-axis. If you think about it, this exponential, it is an increasing exponential. This one, y is equal to 2 raised x. And do you agree with that one?
Yes.
And there's a horizontal asymptote here, and y is equal to 0. Because your, what is it? Your exponential have a horizontal asymptote here, y is equal to 0. Then if you have an horizontal asymptote is equal to because y is equal to 0, how is it going to cross and get to -4? It's not possible. So this is no way. Cancel that. So the only valid x value is that one. Does it make sense?
Yes.
Okay. So we're done with 1.1.4. Now I'm going to clean the board and we'll make space for 1.1.5. What do you think?
Yes.
Okay, so now we're done with 1.1.4. We're going to do 1.1.5. Are you ready?
Yes.
Okay, let's go. We're still solving for x. They want us to solve this thing. So the first thing that you need to do when you're solving this said type of equations, you need to isolate this a root, a square root. So take this thing to the other side. Are you with me? So what you will have, you'll be left with this isolated root here, which is minus 2x plus 4. Are you with me? Is equal to your x plus 2. After it's isolated and is sitting on its own, you square both sides. Are you with me? So this and that go away. Here you'll be left with minus 2x plus 4. Are you with me? Is equal to what? Is equal to the answer to this. So you multiply these two brackets because these are two brackets, which is this bracket times this bracket. Are you with me? So in that case, it will be, if you multiply this bracket out correctly, should be something along the lines of x squared plus 4x plus 4. Are you with me? Let's take this to that side. So we say 0 is equal to x squared, right? Plus 4x plus 2x, which is taking that one over there, plus 4, which is that 4, and minus the other 4. So these two 4s go away. Are you following me? So what you're left with 0 is equal to x squared plus 6x is equal to 0. Then put this in the quadratic formula where your c is equal to 0, or you factorize it. So you can say plus 0, that is your c if you want, and then use the quadratic, but I'm not going to do that. Just take out the common factors. Okay, x, I'm left with x plus 6 is equal to 0. Are you happy? So our x is equal to 0, or our x is equal to minus 6. So it is important to test these x values and see if they do make sense. If your x is 0, are you with me?
Yes.
You put a 0 there. You'll be left with the square root of 4 minus 0, which is 2. So this x is equal to 0 will work perfectly. Are you with me? Now, let's say we have minus 6. Minus 6 times 2 should be 12 there, right? Plus 4, that is 16. Are you with me? So you have square root of 16, which is 4, minus 6, which will be something not 4, which will be something that will not be 2. So it's something that is going to be bigger than 2. So I will deselect this one. Are you happy with this?
Yes.
So I'm saying, if you put this minus 6 there, it's going to be 12. 12 plus 4 is 16. Square root of 16 is 4. Are you with me? So you have 4 here. And then not 4, you are adding what is 6. Because if you substitute the minus, it will be positive. So this is 10. And 10 is not equal to 2. Are you happy with this one being deselected?
Yes.
Okay. So we're done with this one. Now, we're going to move to 1.2. At 1.2, they are saying at 1.2, solve for x and y simultaneously. So they've given you two equations. They want you to solve for x and y at the same time. Are you with me? So the first equation that they've given you is what? Is 2x plus y is equal to 3. Are you happy?
Yes.
And the second one is y squared plus xy is equal to 2. Are you happy with this? So if you're given these two equations, you must look for the one that looks easier. It looks like the first one looks easier to me, this one. Let me just put this in the box here. This equation, 2x plus y, looks easier because there are no squares, there are no product of x's and y's. Are you with me? So if I read it, it says 2x plus y is equal to 3. The other one is y squared plus xy is equal to 2. So when you are given this, go to the easier one equation and try to make x or y the subject of the formula. Are you with me? try to make the one with the lowest coefficient, which means let's try to solve for y here. If you try to solve for y here in this equation, you take this to the other side, right? You'll be left with y is equal to x, oh, what is it? It's 3 minus 2x. Are you with me? So this is the rearrangement of the first equation. We rearranged this equation. So this is exactly this, but it's just rearranged. Are you with me? So now what we're going to do, we're going to take this one and substitute on this equation here, the second one, the one that you have not used. You can see you said your y is equal to this, right? So on this equation, the complex one, the one that you didn't choose, where you see y, you're going to substitute this thing, which is you can see y here, right? Which you're going to substitute this thing. You can see y there as well. You're going to substitute this thing. Are you happy? So in that case, what do you have? You'll have that. I said it's y squared plus xy is equal to 2. Are you happy? The y, what is y? Y is 3x minus 2. So you're going to have a bracket of 3, or of 3 minus 2x. Sorry. 3 minus 2x. Are you happy? All squared because y is squared. Plus x times y. What is your y? Your y is 3 minus 2x. And this is all equal to 2. Are you happy? So we multiply this thing out. So if you multiply these two brackets out, these two brackets here, it's going to be 9, and then this and this is going to be minus 12x plus 4x squared. I'm not sure if you're happy with this multiplication of mine. Are you happy? Plus x times 3 is going to be 3x minus 2x squared is equal to 2. Are you happy? Then what we'll have to do is just add the common factors. Then this and this are together. They will make 2x squared. Are you happy? This and that go together. They will make what? Minus 9x. Are you happy with that? And then now, the numbers, we have a 9. With me, we have a 9, which is plus 9. Then you minus that 2 from the other side. It's equal to 0. Are you with me? Because you took the 2 to the other side. If you do this, you'll find that this is called what? 7. So, from here, you can factorize this thing. Are you with me? You can factorize or use your, what is it? Your quadratic. So let's say you have 2x and an x. Are you with me? And let's say you have a 7 and a 1. Are you with me? And you can see that the sign of the middle term is negative and that one is positive, which means the sign will be the same, and those same as negative. So, if you say this times this, it will give you this. If you say this times this, it will be that. If you cross multiply, you get minus 2x, the term later, minus 7x. When you give them, add them, they give you minus 9x, which is what we have there. So those are our factors. So in that case, take these two factors of yours, your 2x minus 7. If you don't know how to factorize, use your quadratic formula. Times x minus 1 is equal to 0. Are you winning so far? Are you winning? So the product of two things again is 0. What does that mean? At least one of them is 0. One of those brackets is 0. So it's either your 2x minus 7 is equal to 0, which is this part, or your x minus 1 is equal to 0, which is the second part. So in that case, you solve for x here. You get that your x is equal to 7 over 2. Are you happy with that? Or your x equal to 1. Now, what are we missing? We're missing the y values. So if our x is 1 over 2, our y, we're going to substitute that 1 over 2 here. So 7 over 2. Our y is equal to 3 minus 2 into 7 over 2. Are you happy with this? So this and that go away. You get that your y is equal to minus 4. Are you happy with this?
Yes.
Yeah?
Yes.
Okay. So your coordinates is 7 over 2 and minus 4. This is your coordinates for that point. So for the second one, it's okay. If our x is 1, our y is equal to 3 minus 2 into 1. Therefore, your y is equal to 1. So your coordinates is 1 and 1. There we go. Are you happy with this? So we're done with our simultaneous equation, which is 1.2. Any questions for me? No. So now we're left with one question, which is 1.3. Right? I'm not sure if I should clean the board to 1.3 or try to use the space here. What do you think?
Place the board.
Okay, so let's clean the board and then we do 1.3. Okay, so now we're doing 1.3, right? So 1.3 read as follows. They are saying consider the product. So they want you to think about the product of these things here. And you can see they continue, right? No problem. Each factor of this product is in the form 1 plus 1 over n, for n is greater or equal to 2. So we are told that for all these products, right, they are all in this form. Are you with me? For n is greater or equal to 2, which is the smallest possible value of n is 2. Are you with me? No problem. They are saying determine all the values of n for which the product will be an integer. Are you with me? So they want you to find all the values of n that will give you a product that will be an integer. Are you following me? What is an integer? You know integers, it's this set here. It's containing 0, 1, minus 1, 2, minus 2, 3, minus 3, and so on. So you want the product, right, to be an integer value. Determine all the values of n for which the product will be an integer value. You want the answer to this product to fall into this set, to fall into one of the numbers that are here. So it will be 5 and -5, 6, -6, 7, -7, and so on. So you want the product of these. You want for which values of n, what should the value of n be, so that this product falls here on this set. Are you happy with that? No problem. So they're saying each of these vectors is in this form. So let's simplify this. Right? Let's call maybe Pn, which is the product of n, Pn to be equal to 1 plus 1 over n. Are you with me? So if you simplify this, it says over 1 here, right? This time this it will be 1. Are you with me? It will be n, sorry. Then you cross multiply. This time that is n. This time that's 1. So your Pn, which is your product of your vectors, is defined by that. Are you with me? So if you start at 2, it will just be the first one. If your n is equal to 2, it will just be the first one. Are you with me? If your n is equal to 3, because your n values increases from 2 going up. Are you with me? If your n is equal to 2, you'll have two things. Sorry, if your n is equal to 3, you'll have this one and this one multiplying each other. If your n is equal to 4, you'll have all three of these things multiplying each other. Are you happy with that? So in that case, what do we do? It's okay. Let's find P1 or P2 actually. P2 is equal to what? P2 is equal to substitute here, 2 plus 1 all over 2. This is equal to 3 over 2. Is 3 over 2 in this set? So 3 over 2 is not an integer. Let's go to the next one, P3. P3, we should multiply from the first one to the third one that we are going to. Are you with me? So in that case, what do you have? You have the first one, which is this, which is the same as this one here. Are you with me? Because that's P2. So you have your 3 over 2 here, times the next one. What is the next one? The next one that you're looking for would be your P3, which is substitute your 3 there. What you have is 3 plus 1 all over 3. What is the answer to this? So this and this go away. Are you with me? So this is 4 and this is 2. If you punch all of this to your calculator, you should get something along the lines of 2. Are you happy with that? Look at this. Is this number on this set? Yes, it is on this set. And the value of n was what? Was 3. That gave us that. Are you happy with me? Are you happy? No problem. So now let's go to the next one, P4. P4 is equal to the first P1, which was 3 over 2. Are you with me? The second one, which was what? It was that. It was 4 over 3. But now, 1 for here. To get the 1 for here, it's substitute there. So it's going to be 5 over 4. Sorry? It's going to be 5 over 4 because you put your 4 there, plus 1 to be 5 over 4. Are you with me? If you punch this in your calculator, you know this already is 2, right? Because there it is. So it will be 2 times 5 over 4. So it will be 5 over 2. If you punch all of this, it will also give you 5 over 2. So 5 over 2 is equal to what? 2.5. And this one is equal to 1.5 here. Is 2.5 part of this set? So 2.5 is not an integer. So we're not looking for this thing here. So which is your n is equal to 4. Doesn't work. Let's go to the next one. For n is equal to 5, right? Let's go for P5. P5 will be the first one, which was 3 over 2. And then the next one was 4 over 3. The other one was what? It was 5 over 4. Was it the last one? Yeah. That one. Now, let's go and start with the 5. The 5 will be 6 over 5. So punch all of this on your calculator and see what the answer is. But so far, we know that this is equal to what? This is equal to 5 over 2, as we've discovered there. So this is 5 over 2, the 5 and the 5 are going to go away. It's over 2, then you're going to divide the 3, the 6, and you are going to get a 3. Is 3 an integer? There is it. So this answer ours, it falls on that set. It is an integer. And it's happening at P number 5. Look where it started happening. For even numbers, for this even number 2, it didn't happen. For this odd number 3, we got an even number. For another even number, we didn't get an integer. Are you with me? Look for this odd number. For this odd number here, look, we're getting the 3, which is also an integer. It looks like we're getting integer only when our n is odd. When our n is odd, is an odd number, that's when we get the product of factors being an integer. So what I'm going to guess now is that for P6 it will not work. We'll not get an integer. But maybe for P7 it will work. So in that case, I would think it is safe to assume that it will work from there going forward. Are you happy with that? So in that case, what do we say? We say, okay, let's go and find P7, P6. What are we going to have in P6? We'll have all things that are going to, from n is equal to 2 up to 5, which is all of this. Are you with me? And you know all of this is equal to what? It's equal to 3. Are you with me? Because this is all of these things before you add for n is equal to 6. So this will become 7 over 6. So if you punch this in your calculator, it should be something along the lines of 7 over 2, which is 3.5. Is 7 over 2 an integer? No. You see, it didn't work for another even number as well. So now let's go and check it for odd number 7. If it worked for 7, I'm comfortable concluding that it worked for odd numbers starting from 3 going forward. Are you with me? So what are we going to say? So okay, P7 is equal to, it will be everything before it, which is all equal to 7 over 2. Are you with me? Times what? Times 1 for n is equal to 7. So it's going to be 8 over 7. So this and that go away. So you have 8 over 2, which is equal to 4. So this worked for 3. This worked for n is an element of 3. It worked for 5. It worked for 7. I think it will work for 9 going forward. So it will work for all odd numbers. Right? Starting from 3. Actually, for all positive odd numbers. Starting from 3. I'm not sure if you get it. So which means if your n is a positive odd number, greater or equal to 3, then this will work. So n should be one of these values that are here. I'm not sure if you're happy about that. Are you happy? Then I guess we're done with question 1. We'll have to move to the next question, which is question 2. And I hope it does make sense to you, as it does to all of us. Thank you for watching.